In this video, I'll show you how to work with the binomial probability distribution in Excel. So let's do a simple example. We have 3 customers entering a clothing store, and on the basis of past experience, the store manager estimates that the probability that any one customer will make a purchase is 0.3. Okay, so this is set up as a binomial experiment where the sample size n is 3. The probability of success, or in this case, making a purchase, is 0.3. And so with 3 customers, we could have none of the customers making a purchase, 1 of them making a purchase, 2 of them making a purchase, or all 3 of them making a purchase. And to calculate the probabilities of each of those events, we're going to use the probability function, which I've written here. So this is going to use one of the inbuilt formulas inside Excel. And so it's called binom.dist, and there's 4 arguments that we need to enter. If you're not sure what those arguments are, if you click on fx here, it'll bring up a formula builder and it'll tell you what each of those arguments should be. So it's telling me that the first argument is number S. That's the number of successes in the trials. So that's what I'm calling X. Okay, so that's why I've written C2 here. And then the next number is the number of trials. That's N. So that's A2 over here. And then the next number is the probability of success in each trial. So that's P. So that's this number here, B2. And then the final argument says it's a logical value for the cumulative distribution function, use true, for the probability mass function, use false. And that's what we want in this case, is the probability mass function. So I've typed false into that 4th argument. And then I hit return, and it calculates that probability. So the probability that out of those 3 customers, none of them will make a purchase is 0.343. If I wanted to calculate the probability for x equal 1 and 2 and 3, I could copy that formula down, but you'll see there's a bit of a problem if I do that. Okay, it's confused. This means that Excel is confused when it does something like this. And we can see why. If I look to see what my arguments are now, well, C3 is correct. It's picked up the right number there, but A3 and B3, there's nothing there. So what I want to do is I want to fix these 2 arguments to be A2 and B2. So if I go back up here, the way that you do that is to put a $sign before the row number. Okay, that way, if I copy it down, now it works. And you'll see A2 and B2 stayed the same. The only argument that changed was this one, changed from C2 to C3. Okay, a little bit of an Excel tip there. So there's the other probabilities. Okay, so probability that 1 of the customers will make a purchase is 0.441. Probability that 2 of them will is 0.189. Probability that all 3 will is 0.027. Something else we might be interested in is the expected value. In other words, for this example, what's the expected number of customers who make a purchase? And the formula for that is N times P. Okay, so in this case, this number times this number comes to 0.9. And then the variance is N times P times 1 minus P. So it comes to 0.63 in this example. Once you've got this set up in Excel, it's very easy to make some changes. So for example, if I was to increase the number of customers to 10, then that changed n to 10. And then I can copy this formula down all the way. And let's get a few more decimal places so we can see exactly what's going on here. Okay, so there's the probability, all the probabilities for 10 customers. So probability no one bought anything, one person bought something, two people bought something, and so on. And then you'll see that the expected value and the variance updated automatically. I didn't have to change those. Okay, so that's how to use Excel to work with the binomial probability distribution.